Dear students, today we discuss integrals. Integrals coming under 12th standard CBSE Mathematics chapter 7. Integration is inverse process of differentiation. Suppose you are given a derivative of any function and you are asked to find out the primitive function, that is the original function. We have to integrate. This process is called integration. And this is also called antiderivative. Now we discuss some of the basic formulas that are coming under integration. You should have little knowledge under differentiation for integration. As you all know that differentiation of x with respect to x is 1. And so integral of dx, I told you that integration is the antiderivative. So these two come together. So this is going to be simply x. And I can even add c. This constant is because derivative of any function is unique, whereas integration of any function is not unique. So it may differ by constant. So we have to add c. And you know that derivative of sine function sin x with respect to x is cos x. And so we have integration of cos x with respect to x is sin x plus c. And you know that derivative of cos x is minus sin x. Therefore, integral of sin x with respect to x, that is, and which is equal to minus cos x plus c. And one more thing I want to tell you that sin x, this is integrand and x is the variable with respect to which we are integrating. So here cos x is integrand and x is a variable with respect to which we are integrating. So this is integrand and this is variable. And similarly, you know that differentiation of tan x is secant square x, and therefore integration of secant square x with respect to x is tan x plus c. And similarly, derivative of cot x is minus cosecant square x, and therefore integration of cosecant square x dx is minus cot x plus c. And then differentiation of secant x is secant x tan x. Therefore, integration of secant x tan x with respect to x is going to be secant x plus c. And then derivative of cosecant x is minus cosecant x cot x. Therefore, integration of cosecant x cot x dx is going to be minus cosecant x dx. What is derivative of tan inverse of x or secant tan inverse of x, whose derivative is going to be 1 by 1 plus x square. Therefore, integration of 1 by 1 plus x square with respect to x is going to be tan inverse of x plus c. And similarly, differentiation of sine inverse of x is 1 by root of 1 minus x square. And therefore, integral of 1 by root of 1 minus x square with respect to x is going to be sine inverse of x plus c. If at all negative comes, if at all derivative of cot inverse of x, you know that minus 1 by 1 plus x square. Therefore, minus 1 by 1 plus x square with respect to x is going to be cot inverse. Similarly, cos inverse, whose derivative is going to be minus 1 by 1 root of 1 minus x square. So in such case, 1 by root of 1 minus x square is also equal to minus cos inverse of x. So these are all the formula that we have to study. Okay. basically. Then we have, you know that derivative of exponential, that is e power x, is again e power x itself. And therefore, integration of e power x with respect to x is going to be e power x itself. And we generally use the chain rule. You remember, we have differentiation of sin ax with respect to x is going to be, differentiation of sin x is cos x, and using the chain rule, differentiation of sin ax is cos ax, and using the chain rule, we multiply the derivative of ax. Ax derivative is a, so we have to multiply. Whenever we differentiate sin ax, which is going to be cos ax, and we have to multiply this a is nothing but the derivative of ax. Similarly, in the case of integration of sin ax, generally what is integration of sin x? Integration of sin x is minus cos x. In integration of sin x is going to be minus cos x. So that here we have minus cos ax. Here we have to divide the derivative of the argument. Here the argument is ax, whose derivative is a, that has to be divided. So it is something acting like an inverse. And similarly, as I told you, exponential derivative e power ax, whose derivative is e power ax itself, but we have to multiply using the chain rule. We have to multiply the derivative of the power. So this is not e power x, but something e power function of x. So whose derivative is a, that has to be multiplied. Whereas in the case of integration of e power ax with respect to x is going to be e power x is, whose integration is e power x itself. So we write e power x itself. But here this x is not x itself. We have function of x, and whose derivative has to be divided. So this is how we do. Similarly, we discuss one more example. That is, we know that derivative of cos ax. Derivative of cos x is minus sin x. So that we get minus sin ax. But here we don't have simply x. Here the argument is function of x. So whose derivative we have to multiply. Whether it be 2x or 3x, whatever it is, we have to, 2x derivative is 2. That has to be multiplied here. So similarly, in the case of integration, we know that integration of cos x is sin x. So integration of cos 2x is sin 2x with respect to x. With respect to x is sin 2x, but this is not x itself. This is function of x, whose differentiation is 2, that has to be divided. So this is how we integrate. So we have gone through 13 formulae under integration. Now we have problems under 7.1. First problem is integrate sin 2x with respect to x. We know that integration of sin x is minus cos x, so that which is going to be minus cos 2x, but here the argument is not simply x, which is a function of x, so whose derivative is 2, which has to be divided. And the second one is going to be integral of cos 3x dx. Here the argument is 3x. Integral of cos x is going to be sin x. So this is sin 3x, but 3x whose derivative is 3, which has to be divided. Then integral of e power, third problem, is 2x. E power x whose integration is e power x itself. So e power 2x is e power 2x whose integration. But this is not simply x, which is a function of x. So whose derivative has to be divided. 2x derivative with respect to x is 2, which has to be divided. Then adding the constant. Then you know one of the formula that x power n dx, whose formula with respect to integration, that is integration of x power n dx is nothing but x power n plus 1 by n plus 1. So using this formula, we integrate the next problem. That is the fourth problem, which is integral of ax plus b the whole square with respect to x. Here let me consider the whole term as x itself. Okay, x square whose integration is going to be x power 3 by 3. That is ax plus b the whole cube by 3, whereas we don't have x itself. If at all x square dx we can integrate, whose integration is x cube by 3. Here we don't have x but the function of x. What is the derivative of ax plus b with respect to x, which is going to be a? That has to be divided here so that we get 3a. Again I explained, x square with respect to x whose integration is x cube by 3. Here we don't have simply x but ax plus b whose derivative is a, that has to be divided here. Let me discuss the fifth problem, that is integral of sine 2x minus 4 e power 2 or 3x with respect to x. We can use the linearity, that is this can be separated, that is integral of sine 2x dx. I can separate this term because this is linear with respect to addition and subtraction. Integration is, I am using one of the property. So now I can separate this. I can even take 4 outside. This can be written as e power 3x dx. As you all know that integral of sine x is minus cos x. So integral of sine 2x is minus cos 2x, and the derivative of 2x is 2, which has to be divided here, and I have minus here 4 outside. Then e power x integration is e power x itself. So e power 3x integration is e power 3x divided by the derivative of 3x, which is 3 plus c. This is how we integrate.